Hi, I'm Steve Orrin from Intel, and with me on the stage here we have Richard Bruner from VMware, Rob Plansky from RSA, and today we're going to talk to you about how to attest host platform security for cloud deployments. So the first part we're going to talk about is a little introduction into some of the challenges around cloud and virtualization in the cloud. And I guess I'll start with a sort of level setting with the famous cloud as a service triangle. How many of you have seen some form of this triangle before? Okay, a couple of you. So for those that haven't, a lot of people look at the cloud and they sort of break it up into these three subcategories of as-a-services. The topmost one is software as a service. Think about Salesforce.com or Google Apps or things that would fall into that kind of category, where the service provider is providing you a full application stack and the functionality all together, and you just subscribe to that service. Platform as a service is a level below that, where they're providing you with a platform to build application functionality and deploy it into the cloud infrastructure. Think Google Apps Engine or Oracle Web Services as the model there. The one we're going to spend the time on talking really about today is infrastructure as a service. And infrastructure as a service is where they're providing the compute environment and the virtualization infrastructure, but the tenant or the customer is responsible for building not only the application functionality, but the environment by which that application will run. So basically the VM and deploying that VM into a cloud infrastructure. Examples are things like Amazon EC2, products and services from Terramark, and others that allow you to be able to deploy your compute, your workloads into a cloud environment. Some of the challenges when dealing with a cloud is that one of the fundamental changes from your internal data center when you move to the cloud is that you no longer have physical control over those workloads, over the environment and infrastructure that they run on. So the question you need to ask yourself is, so how do you gain visibility into your cloud provider's infrastructure as a service? How do you assess the actual security posture? So how do you know that they've done that? They say in their SLA they've done the right thing. How do you know? How do you validate that? How do you trust the measurements that they're performing on their hardware and on their virtual infrastructure? And ultimately, at the end of the day, how do we then turn around and prove that we've done the right thing and our cloud provider's done the right thing, and prove that to our both internal and external auditors, whether it be for internal policies or government or industry regulations? How do we get the message and the validation out to those people who need it, who are also ultimately assessing us and our ability to meet the requirements? So we start talking about security in the cloud, and there's a lot of studies out there, and you get various different numbers. We're quoting one here from CIO Magazine. 51% say security is one of the greatest concerns surrounding cloud computing and the cloud computing adoption. And the main reasons they give is they need to gain visibility. How do I maintain control in somebody else's infrastructure? And ultimately, like I said before, how do I prove compliance? And this is something that CIOs and CISOs are worried about and trying to figure out. If you flip the viewpoint and start thinking about it as a tenant of the cloud, start asking questions of what are the things that tenants want to do? Well, they want to be able to, their provider, to be able to provide following security practices to make sure that they're doing things like VMware hardening guidelines and all the normal hardening infrastructure and surrounding services to make sure that the virtual and physical infrastructure is protected in their hosted environment. They want to be able to pass the audits. One of the examples we're going to walk through later today is a FISMA example, but PCI and other kinds of audits that these workloads are associated with, they need to be able to pass those. That includes both passing from the workload perspective, the data handling, all the way down into the virtual and physical infrastructure. And finally, they want to be able to be assured that when they're going to deploy their security controls into these environments to manage and govern their workloads, they want to make sure that they're doing this on top of a secure foundation, that the hardware and software and virtual infrastructure has been booted securely and is protected from things like rootkit insertion and other kinds of tampering. So what we're going to do is, for a brief moment, we're going to dive into some of the top security concerns when dealing with cloud and virtualization infrastructures. And the three we're going to talk about is hyperjacking, some risks around co-tenancy and an example of an attack there, and then some of the challenges around regulations. So quick show of hands, how many people have heard the term hyperjacking? Okay, about a third of you guys. Great. So hyperjacking is a unique attack specific to virtualization technologies and virtual environments. The idea is that the attacker injects or inserts a malicious or rogue hypervisor underneath the operating environment, underneath the existing virtual infrastructure. Now, this rogue hypervisor now has access to everything. All the I/O, all the data, all the memory, everything that the virtual machines or the OS has above, this rogue hypervisor or blue pill has the ability to access and therefore either manipulate, steal, or compromise in a variety of different ways. And there are some really good papers that have been written about this. There's the Subvert paper out of the gang from University of Michigan. There's the blue pill attack that Joanna Rakowska published from Invisible Things. What's interesting about these attacks is that they are scary. They're sexy because they can get total control of my environment. But there hasn't been yet a live exploit. And the reason is that a lot of things really have to go wrong in an enterprise or in a virtual infrastructure for someone to perform these kind of hyperjacking attacks. So they're more of a perceived risk than a real risk today, but they are scary and they are something ultimately you need to plan for. But we haven't really seen a whole lot of actual activity because a lot of it requires you have to have physically compromised your data center, or you have to have such a large gaping hole in the infrastructure to allow me to do this kind of insertion that the data has already been owned anyway. There are easier ways to attack the data than going through the blue pill. That said, there are other kinds of problems that have come up that are more tactical and are more real. One example is the research that was done by the UCSD and MIT students. And it was a two-pronged attack. The first phase of their attack was to get their rogue VMs, so they created a whole bunch of VMs, put it into the Amazon cloud, and by doing very accurate analytics on the performance requirements of various different VMs and workloads, were able to guide their rogue VMs such that they were able to land them on the target system of the host that was hosting the VM they wanted to attack. So stage one was to make sure to physically co-locate their rogue VMs, they needed two, so they got two VMs onto the same physical system that was hosting the target that they were trying to come after. Phase two of the attack was, once they were there, performing very interesting side channel attacks. So being able to measure the response times when different workloads were put into those rogue VMs, be able to measure the deltas in performance of the system and on the response. They were able to get some very interesting information leakage out of the target, specifically what web server they were running there, what ports were open, what services were available, what version of the web server. And once they knew that, they said, oh, it's running Apache 4.1 or IIS 5. Then they were able to go look and say, what are the known vulnerabilities for that web server, and attack, and go after it. So this co-tenancy problem is a much more tactical problem, and it's a more real problem because, let's face it, out there in the cloud and out there in virtual infrastructures, we don't have a whole lot of control of who's running next to us and what that thing next to us is doing. Is it a legitimate company? Is it a hacker? Is it a rogue VM? Is it a competitor? We don't have a lot of control over that. So we want to be able to implement some controls that help protect our workloads from exposure to rogue workloads running in the same cloud infrastructure. There is a link there to the paper they wrote. It's a really good read if you're interested in it. You can pull it down from the UCSD website. Finally, so if we step away from the really hacker kind of threats and we start looking at some of the regulation challenges, and I'm picking on two here, but all of the regulations all have various unique challenges when dealing with cloud environments. One is the FISMA challenge, and this is from the NIST SP800-53 guidelines, subsection SC7 around boundary protection, about being able to control both what boundaries you have for your workloads and for your applications, and making sure that those workloads don't go away and don't move to unknown places. When you delve deeply into the regulation, one of the other key requirements there is that you have to make sure that your workloads are maintained within the borders of the US as well, and that they're not being run in other countries. This is an important thing for FISMA. So what's needed is a set of controls that we can make sure that any workloads associated with FISMA activity has been provisioned and isn't migrated to non-US locations. When you look at PCI DSS and you start looking at some of their requirements and the guidance and further guidance we're not only getting now but will continue to get from the PCI Council, things like being able to implement only one primary function per server, nice and vague, but what that basically means is that if I'm going to put an application workload, I can't have database workloads there. I don't want to have non-PCI workloads running on the same server as a PCI workload, and be able to disable all unnecessary or insecure services and protocols on that system. So how do we make sure that whatever provisioning and tuning we do for the PCI controls are being implemented by our cloud provider? So to answer that question, we're going to look at a series of technologies that have come together between VMware, Intel, and RSA to allow you to achieve this goal. And the first step of that process is Richard Bruner from VMware. Thank you.
No, I guess not. Oh, here we go.
That's the laser.
Yeah, good. Okay, good. Okay, so let's start with a chain of trust and how we can use low-level hardware and software components to provide a chain of trust to build a compliant solution on top of, so that then we can look at some really cool solutions from companies like RSA that can build on this. So I hope that maybe we don't have to convince you too much that a compliant, secure cloud needs a chain of trust that is rooted in something reliable, like hardware, that extends to include the hypervisor. And for VMware vSphere to be part of that chain, we need to be able to boot securely and attest to our identity in a reliable way. A chain of trust is established by validating each component of hardware and software from the bottom up. So the trustworthiness of each layer is measured and validated by the one before, all the way back to the starting point, the secure root of trust, which is called the trust anchor. Now, Intel Trusted Execution Technology in the Xeon 5600 series processors, which you may know as Westmere EP processors, can provide the trust anchor by using this trusted execution technology from Intel and a little bit of software from VMware. So what are the hardware and software components at the low level that you need in order to sort of put together this secure root of trust? And so I have two slides that talk about it. What I'm trying to show here is a Westmere EP-based server, also known as Xeon 5600-based server. And the hardware has various support. So the processors themselves have support for TXT, Intel Trusted Execution Technology. And then the chipset here, the Tylersburg chipset in such a platform, actually also has support for TXT and I/O isolation domains. This is going to be important because this component is going to protect the memory that is attached to these processors from attack by I/O devices that might decide, hey, I want to do DMA to memory while the processor is booting, while the OS is actually loading itself, and try to attack the OS as it's booting. So that's an important piece of the puzzle as well. And then finally, a thing here that is showing up on servers, you may not even realize this, is the Trusted Platform module. This is a piece of silicon that's made either by Infineon or ST Micro or other companies like that. And this is a cool device. It implements both a secure place to store secrets, as well as it has a nice little hashing engine in it, an encryption engine in it that can be used for a number of things. We're going to use it for secure boot. And inside this TPM are special registers called platform configuration registers. These registers, you can never write directly to them. You can only take their previous contents, append them to a new value that you're interested in writing, and then that is hashed, and that value is actually stored in the registers. So there's no way for malicious software to get in there and jam in a value that it thinks is the right answer. And the only way these registers can be reset is by well-defined events like a hardware reset. So that's pretty tamper-resistant. Let's see, what else do I want to talk about? So again, TXT provides that secure boot, secure launch environment, and a way for us to measure the OS and other components as we boot. And this measured launch environment really is tamper-resistant. It's safe from attack by BIOS itself, believe it or not. It's safe from I/O devices that might try to DMA into memory while you're booting. And it's even safe from software that runs ahead of the secure bootloader. So it's pretty cool stuff. Then the software components necessary to finish this story is the ESXi version of vSphere, which includes a trusted boot manager. This trusted boot manager is similar in intent to the open source trusted boot manager that you might be aware of, but it's a completely different code base. But it is the the starting step that allows us then to use TXT to boot. The other software components here is once we've actually managed to boot the system, we'll go ahead and vSphere can communicate to vCenter the secure measurements of the various software components as we booted. And these can be used to be compared against known good values and can be used to attest to the identity of the software that has booted on the vSphere, or as I like to say, ESX host. And then finally, using the virtual infrastructure SDK that we have available, a third-party application can actually be written to use this information to implement compliance policies. And this is the piece that Rob is really going to focus on. This is what ties it all together and makes it an interesting and useful solution for compliance. So very quickly, what sort of happens is, first off, the customer, through his IT administrators or some equivalent process, has enabled TXT, has enabled the Trusted Platform module on their server, and has configured ESXi to boot using the Trusted Boot Manager to use this secure launch mechanism. So when this happens, this boot process, the tboot code, the Trusted Boot code, and a special secure initialization module are going to be loaded into memory, and we're going to transfer control basically from the hardware through the BIOS to this Trusted Bootloader. And the Trusted Bootloader is going to load this secure initialization module that comes straight from Intel that is going to configure the hardware so the memory that we are going to boot the OS from cannot be attacked by any sort of a rogue DMA or any other method. Once that piece of code finishes, it returns control to tboot, and we are now running in a secure launch environment. And from there, tboot hands control over to the VMK boot code, which then loads VM kernel, and then the boot process finishes. So, as part of this process, tboot will check that the system has a secure configuration. It invokes this SNIT module, which actually, as I said, brings us into this measured launch environment, the secure launch environment. And then tboot will actually, on the return, will measure the initial vSphere components. By measure, it will take a secure hash algorithm -1 measurement of our code modules and actually cause that to be hashed into those special registers in the TPM, those platform configuration registers. Then control will transfer over to vSphere ESXi, which will do the same process for all the remaining software components of ESX. It will hash them using the TPM and then store them in particular platform configuration registers. Later on, vCenter through host D can say, what are the values? And they will be transmitted to vSphere in a secure way. So, due to the embedded nature of ESXi, this capability will probably be initially available only in ESXi. The Service Console OS is sort of inflexible to be able to include this kind of technology in it. We only do measurements in vSphere as we are using this secure launch mechanism. We leave launch control policies, that is, what do you do if the platform is not trusted, if the measurements don't match? We leave that to vCenter and the applications running in vCenter to make that decision. That sort of fits our general DNA of the way we like to do things at VMware, is put the intelligence and the policy in vCenter so it can be applied across a range of hosts rather than having to configure each individual host with a launch control policy. So as I've said, vCenter can record the dynamic TPM signatures of those platform configuration registers for each host as it boots. We can allow third-party vCenter apps to provide launch control policies and a database of expected or known good values. These vCenter apps use the VMware Infrastructure SDK to access the values. And as I said before, the actual PCR values themselves, the special registers in the TPM, they're sent securely. They're never sent in the clear. They're actually encrypted by the TPM. vSphere doesn't even have the encryption key, and vCenter has the decryption key. And there's no way that this can be hacked or spoofed. And we'll go in more details offline if you're curious about that. Our initial support will be for Westmere EP processors, and it's likely that we'll have support for other processors that launch that have the similar technology. Now, I can't say when we will officially support this because this is VMworld and we never do things like that, but I can say that a future release of vSphere will support this technology, and we're pretty excited about that. Lastly, vSphere relies on external tools to set up and provision the Trusted Platform module in the platform. So the OEM server vendor will have tools that will either be embedded in their BIOS or that will in some way be shipped with the system where you can configure and set up the Trusted Platform module. And endorsing or taking ownership of the TPM is going to require a reboot of the system. So Intel TXT over time becomes a necessary but not sufficient means of ensuring security and compliance. TXT doesn't prevent the deployment of rootkits after the launch of vSphere hosts. And as I've said before, TXT usage by vSphere merely helps a third party to determine if the right code has booted. But there are other things that we can do to make certain that after vSphere launches, that the hypervisor doesn't get infected. First off, VMware spends a lot of time hardening the interface between virtual machines and the hypervisor so that a VM, a malicious VM, can't leak out of its container and attack the hypervisor or other VMs. But there are also common sense hardening guidelines that we recommend to our customers that are also necessary in order to ensure the security of the host. So TXT isn't a panacea, but it's an important step, and it does build a foundation that then some really cool software from RSA can take advantage of. And with that, I'd like to turn it over to Rob Polanski.
Thanks, Richard. So Steve talked a little bit about some of the security concerns impacting virtualized environments used in the cloud. And Richard described the use of Intel's TXT to create a trusted boot environment and a chain of trust from hardware through the tboot process and into the hypervisor. What I'm going to talk about is how we build on top of that chain of trust to build a solution by which you can prove compliance to regulations, policies, and standards. And as a cloud provider, you can use that to give more confidence to your tenants that they can move their sensitive workloads to the cloud. So when we first talk a little bit about the architecture of what we built in this technology preview, on the left side, we're depicting the chain of trust establishment through the booting of the Intel Westmere processor up through the hypervisor and securely communicating the measurements of that chain of trust as embodied in the PCRs into vCenter server. What we've built is what we're calling an advanced data management layer. Clearly not a product name, but its purpose here is to perform automated assessments of compliance to controls, and specifically here to take a look at those PCRs and compare them to expected values. It also looks at the configuration of vCenter and the hosts to determine compliance with things like the VMware hardening guidelines and other regulations and standards. RSA's Envision at the top there is a security information and event management product that will take historical information through event logs, and it already supports the ability to pull event information from vCenter server regarding your virtual infrastructure and correlate that and help you to determine what types of events are occurring in the virtual infrastructure. The advanced data management layer queries that and uses it again to assess compliance to controls that deal with event management as well as the types of events that can be gleaned from those reports. The results of the automated assessment is then pushed into RSA's Archer eGRC platform. Governance, Risk, and Compliance is what GRC stands for. And the results are related to, when I said controls, I mean specific IT controls, like you must disable unnecessary services. Those in the Archer database are related to specific regulations and standards and policies that actually define the requirements to use those controls. Then, once we've been able to relate the results of of those assessments to those regulations and standards, we have the ability to, through this cloud compliance dashboard, to visualize the actual status of compliance, to be able to answer questions about, am I secure, am I compliant with a particular regulation? On the right side, we're showing potential extension to the preview where we can use the data feed manager capability of Archer to pull in additional information from other systems to provide context about which you can perform your assessments and visualize the information that you're showing in your reports. So specifically, you could, for example, use RSA's data loss prevention technology to classify information within the virtual infrastructure and then only report on, for example, the use of trusted hardware on those resources where you actually care about the use of trusted hardware. In this case, in our use case, FISMA information. So let's switch over to a recording of the demo. And that way we don't have to worry. It's a recording, so we don't have to worry about internet access and things like that, which I've heard are pretty bad here this week. And as a reminder, so the use case one of the use cases we want to talk about is the use of the use case we want to talk about here is NIST's SP800-53 guidance, specifically the section around boundary protection. So at a high level, you read that and you think, okay, I need a firewall. But it's more than that because I actually care about the location of the information that's being processed, not just did it leave that location. Because, for example, if your U.S. government-related information is being processed in a country other than the United States, then it's subject to legal intercept or other types of subpoenas, which then would violate the intent, if not the letter, of that regulation. So, very simply, we don't want VMs to migrate from the USA outside to another country. So we're going to show a couple different aspects of the demo we built. And to get to showing audit and compliance, we're going to start with provisioning of the TPM and enabling TXT, and then move through a couple other steps. So since we're talking about provisioning, you're actually physically provisioning hardware in your data center. And when you do that, you would need to enable TXT and also to enable and take ownership of the TPM, the Trusted Platform Module. That's not enabled by default. What we're now doing, in addition to those somewhat standard steps, is to write a location associated with that hardware into non-volatile RAM associated with the TPM. When we do that, the expectation is that then later on we can read that information back out only when TXT has successfully created that chain of trust. Once you provision the hardware, you need to make it part of your virtual data center. So what we're showing here is very quickly creating a data center, creating a cluster which you identify as the FISMA cluster within the United States data center. All the hosts that we then, in this case, we're going to add the host to the cluster. And one thing that Richard mentioned was enabling tboot. So while you've already enabled the TPM and TXT in the hardware, you also need to enable ESXi to do a trusted boot. So that's a software advanced setting in vCenter Server, and then you reboot the system. I'm going to quickly talk about policy and control, although we're not, this proof concept is not about enforcement of geolocation, but rather audit and compliance with geolocation requirements to meet this guideline. But that is clearly going to be important to the use case as well for a real customer. So in this case, You're going to create a virtual machine labeled FSMA workload 1, and it will reside on the host that's in the cluster. Now, the point that we're trying to make here is that all VMs residing within the cluster inherit the policies of the cluster. So if we're talking about whether the administrators who can operate the VM and migrate it and clone it should only have, for example, rights to manage that cluster. So you won't have a mistaken clone or migration of that machine outside the cluster where all the hardware is located in the United States. Likewise, you might ensure that the DRS pool for vMotion only includes hosts within that cluster. So you wouldn't have an automated vMotion of that workload outside of the FSMA cluster. There are also third-party tools that allow you to enforce policies regarding locations and trusted boot process. This is really a depiction here of what we're just talking about. You would only want the virtual machine to migrate from the server cluster A in the US to server cluster B, also in the US, but not to C. So let's move on to audit, specifically where we're interested in auditing the workloads that are running on those clusters, determining whether the correct workloads are running on both systems that have booted, leveraging Intel TXT, as well as the geolocation. So here it's depicting that what we care about is systems that we would allow only systems that are tagged US. So the last section here, like I said, we're going to talk about audit, specifically the FSMA compliance dashboard. So this is, at a high level, the dashboard within RSA's Archer. And what you're seeing there is first a graph that shows compliance as evidenced by those automated assessments against different categories of VMware's hardening guidelines. Those same results can be used to build a report against a different regulation because the assessments are related to the controls, and the controls exist in multiple locations. I'll talk a little bit more about that later, but the end result is I'm able to assess my infrastructure one time and then report on the state of my infrastructure in multiple ways, depending on the questions the business owners are asking. We can also look at compliance over time. That's another example here. So I've got campaigns over and assessments on a quarter-by-quarter basis. And then I can actually drill down into the details. So instead of it being a business-level view, I can now look at the actual results of assessments of specific controls, helping me to deal with remediation questions if something the assessment was not 100%, which they aren't usually when you first start. You'll want to figure out how to resolve that. So in this case, we're going to drill into that host geolocation and VM cluster membership assessment. Now, what we care about here, if you think about that regulation and the specific requirement, is the cluster located in the US? Are all the VMs that are processing FSMA data running in that cluster in the US? And finally, are they being co-hosted with VMs that should not be there because they're not related to FSMA? What the system we've built does is it allows the administrator here to define flexibly the specific requirements that they have for the different assessments of controls. So in this case, we're going to say, we say, is the geolocation of the FSMA cluster all hosts in that cluster in the United States? This is a flexible configuration language that's defined in we provide an XQuery configuration file that it can be customized by the customer, and then additional capabilities to script additional assessments. So your business logic for a customer is going to be completely flexible. The second assessment is about VM and host geolocation. And just like before, the geolocation here for all VMs that are tagged FSMA are they in the United States? And the United States moniker there, again, would be translated inside the business logic to relate it to the value that's expected to be retrieved from the TPM. So you wouldn't actually get United States, you get a hash value of United States and previous values in the platform configuration register. But at this level, you're not interested in seeing that. Now, this screen here is meant to show a couple things, but specifically I'd like to point out the control standard section at the bottom. Like I said, an assessment is related to a control standard. And within the database, you'll see a little bit more later on in the video, but they're related to different what are called authoritative sources. So a logical security domain's control is actually defined in very similar ways in a variety of different regulations. And then you can actually drill into them to understand what it is that you're being asked to comply with. But first, let's go back to the last assessment for VM co-hosting. And here the logic is that virtual machines within the cluster of FISMA cluster 1, if their tag is not FISMA, not tagged as FISMA, then the result of that query should be the empty set. One thing I forgot to mention before is the tagging of the VMs. In this case, we did it manually, but you could also imagine doing that via the data classification example we provided before. So here we're going to drill down into that regulation we've been talking about, and that's from the location within the database in Archer that talks about that control standard. Logical security domains related to SC7 boundary protection, and then you can actually read the full detail of the regulation within the system. So a cloud provider that actually performs these assessments of compliance to regulations and customer requirements can then provide answers in a service catalog fashion to customers about what offerings they have mapped to what security requirements, very similar to the service catalogs that you saw, for example, in Tuesday's keynote. In this case here, a silver security offering might only comply with VMware hardening guidelines, but the gold offering would comply with the guidelines as well as leveraging Intel's TXT to build the chain of trust to help you achieve FISMA compliance. So the customer in our use case we mentioned before, processing FISMA-related data, they would choose the gold security offering. So let's just ensure that we'll review how we went from chain of trust to compliance. So the chain of trust is proven through PCR comparisons. Are the values that I've retrieved from the TPM as expected? We're also able to uniquely identify the location through a geolocation tag that's been provisioned to the host. The advanced data management layer assesses that the host only boots from a secure root of trust, hosts are in the correct location, and they're in the FISMA resource pool. And only the correct VMs are actually running in that resource pool. And you put that together, and that gives you the ability to meet certain aspects of SC7. Obviously, you still need that firewall, but the point is that now you've covered more than one base for the regulation. So this is a single example of how you can build a compliance solution related to root of trust. I want to spend just a minute or two to drill in a little bit further to the control standard mappings within Archer to ensure that I was clear. If in the center there we see Archer control standards, and pushing into them are the advanced data management assessments. So the results of these assessments relate to a specific control standard, but within the database, there's relations to specific corporate policies, authoritative sources, which are regulations and industry standards, and control procedures, steps to follow to meet those specific controls, like VMware's hardening guidelines. So, for example, you can compare that your ESXi system is only running the expected set of services. And that is identified as a control standard within the Archer database with a specific ID. And in the database, it's related to both PCI DSS 2.2.2 that says you must disable all services and protocols that you don't require. It's also a very specific VMware hardening guideline, so embodied as a control procedure within Archer that says additional software and services that you don't require need to be disabled. Very similar, but they're repeated over and over again in lots of different standards and regulations. So as you see here, a single assessment of one thing within the virtual infrastructure provides answers to more than one concern from the business level. And the example here is related to what we just showed in the video. We want to ensure that all FSMA VMs are executing within US tagged trusted resource pools. So that's the assessment we did. That's related to a specific control standard within the database, which then relates to, as we showed, that SC7 section of SP800-53. It also can be related within the database to a set of steps that you can use manually or automated to figure out whether you are compliant. So, in summary, we found that there's real and perceived risks in the cloud. There's real ones because if you configure things improperly, and you don't follow, for example, vSphere hardening guidelines, then you do have an insecure virtual infrastructure. There's also a real risk in the fact that tenants of cloud providers don't have physical control and they don't have visibility into how things are configured. And the answers to those questions, how is it configured, are actually very relevant and important to meeting their compliance requirements. But there's some perceived risks, right? It's new, therefore I'm afraid of it. And we figure something must be wrong with it. Something's insecure. What we've shown is that these risks can be mitigated, both the perceived ones and the real ones. So Intel TXT provides that secure root of trust, and then combined with the vSphere ESXi boot creates that chain of trust from the hardware up to the hypervisor. And then the Archer GRC solution provides you with visibility into that infrastructure and a process for managing compliance to regulations. If there are any questions right now, just step up to the microphone, please. And thank you very much for attending our session.